Okay, so in this video then, we'll start to look at some of the signals coming in from the Muon detector. So probably from here on after, we don't really need to look at the big black box in the back anymore. It doesn't really do anything. We just sort of need the wires coming from it so we can process the data and start detecting muons. So the way we start then is just to make sure that everything is working inside the black box, which includes the photomultiplier tube, the LED, the preamplifier, and all that good stuff, just to make sure it's working. So that's what I have running here. So as I mentioned last time, this little brown box right here is the preamp, and in the back of the preamplifier I have this cable right here is connected to the one coming out from the detector. So we let the preamplifier do its job, does the amplification, and this cable here then is coming from the timing pulse that comes out of the preamp. So again, we're not discriminating energy. It'll just be a signal, same voltage, independent of the energy, that just marks the time when the event happened. And I just sort of have that going right into channel 1 on the oscilloscope. Okay, so what are we going to drive it with? Well, now you see the value of that LED cable that I mentioned is going in to the detector as well. So this cable right here is connected to that LED, which is positioned right next to the scintillation plastic inside the detector. So when the LED flashes, it sends some light through the scintillation plastic and is picked up by the photomultiplier tube, sort of like a fake nuclear event. Okay? So what I have it connected to in this blue nuclear module right here is a pulse generator. So you can see this blue thing here is called a tail pulse generator. It's called tail because you can sort of program the rising and falling edges of the pulse that are ultimately produced, but there you go. And so we're just flashing the LED. We have it set on a repetition rate of about 1 kilohertz. I'll talk about this knob in a later video here, and the amplitude right here, which is of course the brightness of the LED, is at this point turned all the way up. So supposedly the LED is flashing just as bright as it possibly can right next to the scintillation plastic in the detector there. Okay, so if I do that then, remember that everything is wired up. This cable is going to flash the LED. The LED is going to flash some photons near the scintillation plastic. Those photons are going to get picked up by the photomultiplier tube. The photomultiplier tube is going to send its very, very weak signal into the preamplifier through this cable in the back here that you can barely see. The preamplifier is going to amplify them. We could look at the energies, but we're not. We're just going to look at the timing signal. That is evidence that the signal even came in at all. And so if we see a timing signal coming through this wire here, we'll notice everything's kind of working in the detector on the electronics. So if I zoom in on the oscilloscope, indeed, you can see that there is a nice negative going edge coming from the timing pulse of the preamplifier. So this is what timing pulses look like from the preamplifier. So again, the LED is flashing. These aren't nuclear events, but we can tell that all the electronics are working at least at this level. And there's a couple things you can do sort of to verify this thing, some knobs you can twiddle around with. Like for instance, if I go down here and turn the amplitude way down on the LED flashing, you can take a look at that, what that does. So I'll zoom in on the signal on the oscilloscope so you can see it there. So here we go. I'll start turning the amplitude down. So down, I'm turning that knob, turning it down, and eventually the signal just disappears when, say, the LED just isn't flashing anymore. So we're just getting a bunch of noise. And if I turn it back up again, you can see there's the LED flashing, stimulating the scintillation plastic, getting picked up by the photomultiplier, and so on. So the last thing that I'll do in this video here, so hopefully you're convinced that at this level, that's what the LED's for. And we can definitely see that the electronics are working, at least at this level. So what I'll do lastly to end this video here is I'm just going to unplug this cable that's driving the LED. So in other words, the LED won't flash anymore. And then you can go back and look at the oscilloscope screen to see what happens. So I'll just sort of unplug that, and there you go. So see, of course, the signal goes away, but once in a while you do get a little signal on there. You can see it's not triggered probably because I don't know when the signal is going to arrive, but you can see once in a while we get a negative going signal in there. What is that? Well, it could be a muon, or it could be some other nuclear event, or it could just be noise. Because remember, the black box is all wooden and sealed up in the back. It's that black box again. It's certainly not getting any room light in there. So the fact now that the LED is completely disconnected and you're still seeing some events is, again, noise, a muon, or some other nuclear event that's arriving at the scintillation plastic, causing it to spark and causing the photomultiplier to pick up the light and send the signal through the electronics that I just described.